So we're going to have states fail, heads, head, tail, heads, head, tail.
Yep.
Okay. From the fail state, I can stay in the fail state half the time, or move to heads half the time. And I can't, from the fail state, move to head, tails on a flip. Why not?
Because then you're only doing one flip each time.
Okay.
You can't go from 0 flips to 2 flips.
All right, very good. So then tell me, I'm going to cover it up. Where can I go from the head state?
Let's see, well, you could go to, if you flip the tails, you go to head, tails. And if you flip a head, you stay at the head.
Okay, and that's everything. So I can't go to fail, stay at heads, move to head, tail, can't go to the other ones. Can you tell me from head, tail, where can I go?
From head, tail, you can go to head or to fail. Or to, actually you can't go to head, you can go to head, tail, head. And you can go to fail.
Okay, so you can go from this state, you can go back to the beginning or to head, tail, head. From head, tail, head, where can I go?
You can either go back to head or go to head, tail, head, tail.
Okay, that's what I have here. And then from head, tail, I'm done. I always stay in that state once I get there. That's called an absorbing state. So I make this matrix. Sorry, I need to slide over just a little bit. It's good on camera. And then I'm going to use some code that we don't need to understand right now. And we're going to do something. We're going to make something called a discrete Markov process. But Mathematica makes this really neat graph for us. And can you tell me what this graph is describing?
So the different different paths you can move from each state. So at fail, you can stay at fail. If you go to head, you can stay at head or go to head, tail. And you can go 2 different ways. From head, tail, head, you can go either to this final state or back to head.
Okay. And this next command, first passage time distribution, we're looking for the mean, tells us on average the number of steps it takes starting from the beginning to get to the end.
Okay.
So what is your guess for this one? To get to head, tail. What is your guess as to how often or how long that's going to take on average?
Maybe a little less than 16, because you have a half chance of advancing. Basically, you have a half chance of advancing for every one of these. You can't go like 3 different ways.
Okay.
So, but you can also, if you fail on one of them, you kind of stay at head, so I think it'll be a little less than that. Because you don't go all the way back to the start every time.
What do you think?
I'd say it would be a little less than 16, because you can't, like, when you're right almost at the end, you don't immediately go back to the start. You go either to the end or you go down, not all the way to the start, but almost all the way to the start. So maybe like 14 or something.
Okay. So here we go.
20.
It's actually 20.
So we take more.
It takes longer.
So I guess that might be because that might be because you have like so many things that kind of bounce you around in the middle. Like you can go like this way and you can be in this triangle for a while. You can go this way and be in this triangle.
Yeah, it's definitely a surprise, right?
Yeah.
It takes on average 20 flips of the coin. So that's what we're going to study. We're going to learn a different way of looking at this problem that tells us how to answer these problems almost in our head, which is incredible. And then what we're going to do in the last video is we're going to talk about all 16 cases and how long they take.
Okay.
All right.
So the first one, this head tail takes 20, and then we're going to look at all of them and see
All right.
what we find. All right.
All right.